Okay, folks, take two on this video because I've switched back to my phone because the visualizer didn't work. So, talking about concentration and what actually is concentration. So, concentration is the amount of solvent dissolved in the amount of solute dissolved in a certain volume of solvent. So, solute is the solid, and solvent is the liquid. So it's measuring how much stuff you've got dissolved in a certain volume of liquid. So if we're going to do that as an equation, you'd have the amount of stuff dissolved in a certain volume. We'll make this a bit more technical later, but for now we're just going to go with amount of stuff. So if you had if you look at this equation, right? So you've done this in maths before, so that equals concentration. You've done divisions before. How can you make this number big? Well, you can either make the number on the top massive, so if you have a large number on the top, divide by something, makes a big number, or you can make the bottom number really small, and that makes that a big number. If you divide by a really tiny number, so with a really small volume, you could have a really large concentration. So for argument's sake, you're going to have a huge beaker, another huge beaker. So the volume is the volume's really high with both of these. And if we add a tiny bit of stuff to that, that's going to end up with a low concentration because we've got a small amount of stuff divided by a really big number. So a little number divided by a big number means the concentration is really low. If we put in absolutely tons of stuff into that one, you're going to end up with a big number, loads of stuff, big number divided by a big number. That will be sort of a medium concentration. And then if we went and had really tiny beakers, and if we added a tiny microscopic speck, you'd have a low number divided by a low number. So that would also be kind of a medium-y concentration. Or if we added quite a lot in there, divided by a really small number, we could end up with quite a high concentration. And then to go back to what I said I was going to talk about, so the amount of stuff, that's not a particularly precise term. So how can we measure amount of stuff in chemistry? Well, we're going to start off just using the mass. Mass in grams. So mass divided by volume. Now we need to talk about volume. And volume is obviously a 3D shape. You've done this in maths before. So if we're talking about the volume of something, right, the amount of space it occupies. And in chemistry, when we talk about volume, we talk about decimeters cubed. And so if we had a box that was 1 decimeter wide by 1 decimeter tall, and it was 1 decimeter deep, the volume, you would have 1 times 1 times 1, and that would be 1 decimeter cubed. Now, you also need to be able to change this into centimeters. So if you think of decimeter, which is spelled decimeter, if you think of decade, there's 10 years in a decade, there are 10 decimeters in a meter. So 1 decimeter equals 10 centimeters. We've got to remember this is cubed. So that would be 10 centimeters by 10 centimeters by 10 centimeters. So you would have 10 times 10 times 10, which is 1,000 centimeters cubed. So 1 decimeter is the same as 1,000 centimeters cubed. Now, this is quite important for the rest of the video, so you might want to, after I finish this, just pause it and take notes of what's in this purple box. But you will need to have concentration equals mass, which is in grams, divided by volume, which is in decimeters cubed, and 1 decimeter cubed equals 1,000 centimeters cubed. So how can you turn those into each other? Well, how do you turn 1 into 1,000? You times it by 1,000. So to turn a decimeter into a centimeter, you times it by 1,000. How do you turn a centimeter cubed into a decimeter cubed? Well, 1,000 into 1, you divide it by 1,000. So you might want to just pause the video now, just jot down that purple box into your notes. Okay, 3, 2, 1. Okay, carrying on with the video now. I'm assuming that you've got that down. So, first question. Calculate the concentration of a solution of 15 grams of sodium chloride, which is NaCl, in 3 decimeter cubed of solution. So we go back, we look at our notes. Move it down so you can see it. So first step, let's write the formula out. So we have concentration equals mass divided by volume. Next thing, you get a mark on the exam for plugging the numbers in. Let's just check the units. We've got 15 grams and that one should be in grams. So we can just put 15 grams. Volume, they've been kind, it's in decimeters cubed. So 15 divided by 3 decimeters cubed. And we get our answer, which is 15 divided by 3, 5 grams per decimeter cubed. Just going to add something slightly trickier now. So that is grams, that slash is like divided by, so it's grams divided by decimeters cubed, just like here, grams divided by decimeters cubed. But they don't tend to write like that in science exams. They tend to write it as grams decimeter to the -3. That is grams per decimeter cubed. Just like in physics, where you have meters per second, that tends to be written as meters per second. You get rid of the slash and you make that one a minus. I'm not going to go into details of why that is now. That's a couple of minutes of maths, but for now, just accept where you see grams dn -3, that means grams per decimeter cubed. Right, so we've got the first one done. Go on, just try a second question, which I've written down somewhere else. Right here, 0.25 grams of sodium hydroxide in 100 centimeters cubed of solution. So we go back, we've got our formula. So we go concentration equals mass, which needs to be in grams, and volume, which needs to be in decimeters cubed. We can check. Okay, this time they haven't given us in decimeters cubed, it's in centimeters cubed. So the first thing we need to do is to change and work that out. So we go 100 centimeters cubed. We need to turn it into decimeters cubed. Check our notes. Centimeters cubed into decimeters cubed, we need to divide by 1,000. So 100 divided by 1,000, that is 0.1 decimeters cubed. So now we can put that down there. So the mass, 0.25 grams divided by 0.1 decimeter cubed equals 2.5 grams per decimeter cubed. So that's how you work that one out. And it makes sense if you think about it. They were making, I'll just get another board. I'll just check that you can see all of that. They had a tiny amount, so they were putting 0.25 grams into quite a small volume. And for this unit, we want to know if we were making it into one big decimeter. So that was 0.25 grams in 0.1 decimeter cubed. Well, if we were putting that into 1 decimeter cubed, like in the unit, we've times the volume by 10, so we would have had to make that by 10. So these two solutions would have exactly the same concentration. 0.25 grams in 0.1 decimeters is the same as 2.5 grams in 1 decimeter cubed. Right, next question. This one's slightly different. They've asked us to work out the mass. So they've given us the volume, they've given us the concentration. So we go concentration equals mass over volume. Let's just check the units. That's grams per decimeter cubed, which is fine. Okay, 50. That's in centimeters cubed. So that's in centimeters cubed. So we need to turn that from centimeters cubed into decimeters cubed. So we need to divide it by 1,000. So we have 50 divided by 1,000, which is 0.05. So 0.05 decimeters cubed. Let's put those numbers in. So we know the concentration, we know the volume, tick. We want to work out the mass. So concentration was 10 grams per decimeter cubed. We're trying to work out the mass, which will be in grams. And we know the volume is 0.05 decimeters cubed. So we rearrange that. So the opposite of dividing by, we have to times it. So we get 10 grams per decimeter cubed times by 0.05 decimeters cubed equals, and you're allowed to use a calculator, and my calculator I was using is on my phone, which I'm now using to record the video. So I just have to go and find where I wrote the answer down earlier. Really should have paid attention to this when I was doing it. Come on, where is the answer? Right, I don't know why, it's just timesing it by 10. I'm a muppet, I should just be able to do that. 0.5 grams. Right, 0.5 grams would be the mass that you'd need to use. Okay. Right, the next step, if we go back to the very start, so where I was talking about concentration, and I wrote it as the amount of stuff divided by volume. So I said that was the concentration. We just did all of that as if the amount of stuff was in mass, but with the other way we've got of measuring the amount of stuff in chemistry is we can talk about moles. So you can have concentration in, if we did that, the unit would be moles per decimeter cubed, which is fine. So you can get questions over where if we had 4 moles of something is dissolved in 2 decimeters cubed, what's the concentration? So concentration equals moles divided by volume. So that would be 4 divided by 2, and that would be 2 moles per decimeter cubed. The other thing that it can ask you to do is to turn one unit into the other. So they could ask you to turn moles per decimeter cubed into grams per decimeter cubed, or vice versa. Apologies for the laptop beeping away in the background. So they could ask you to turn that into that, or they could ask you to go back and you just ignore the decimeters cubed bit and you just turn moles into mass or mass into moles using the equation that you should be very familiar with. Moles equals mass divided by mR. So if we go back to the very first question, just to give you a bit of practice at that. So we had calculate the concentration of a solution of 15 grams of sodium chloride in 3 decimeters cubed of solution. And now if they were going to add an extra bit onto that question, they might say give the concentration in moles per decimeter cubed. So we know it's 5 grams per decimeter cubed. We just have to work out how many moles 5 grams is. So we go back to our tried and trusted equation. Moles equals mass divided by mR. We know the mass is 5 grams. We just need to work out what the mR is. For that we can use periodic table. Rather than make you go and find a periodic table I'll just give you the answers. So sodium, Na, has an atomic mass of 23. Chlorine is 35.5. So NaCl has an MR of 23 plus 35.5. If you don't understand how to work out the relative formula mass, then please ask me, because that's sort of a separate video, but that would be 58.5. So we can go back to our question. We know the mass was 5 grams because we've just worked it out. We know the MR is 58.5, and you're allowed to use your calculator for this. Again, I haven't got access to a calculator, so I need to go to where I worked out the answer earlier on. And that was, where did I do it? Naught 0.085 moles. So if we know 5 grams is the same as that many moles, then 5 grams per decimeter cubed is the same as 0.085 moles per decimeter cubed. So you just ignore the concentration bit, just turn grams into moles and work it out. Exactly the same if they gave you moles and asked you to do it into mass. You just rearrange this, moles times MR equals mass, and go through it that way. Okay, hopefully that's helped.